Okay, so we are going to take a look at the vertical structure of the atmosphere. Now, in your book, this material is covered in section 16.3. So what we're going to be talking about right now are two diagrams. First is the diagram on page 492, which is right here, which is the diagram of pressure with altitude. And then we'll also be talking about changes in temperature in altitude. So there's a lot of material on these pages. This video is just to provide a summary. Now this handout I've provided for you online in case you want to follow along. So if you want to print it out, take notes on it while you watch this video, this might help you. Keep in mind that I may ask you to recreate one or both of these graphs on the upcoming exams. So, let's take a look at the different layers of the atmosphere. So the major layers of the atmosphere are the troposphere, the stratosphere, the mesosphere, and the thermosphere. Now, the troposphere is important to us because in the troposphere is basically where everything that you're familiar with happens. And the troposphere starts right about here. Now, it's important to keep in mind that the troposphere isn't always the same thickness everywhere. For example, at the equator, the troposphere is much thicker than it is at either of the poles. Now, in the troposphere, you have all mountains and land features. And it's also where your weather occurs. So the troposphere is where the action is. It's also where you are right now. And the next layer above that is the stratosphere. And the stratosphere runs up to about 30 miles above the surface. Like the troposphere, it doesn't have the same uniform thickness all around the globe. There's differences in thickness in the stratosphere and the troposphere, partially due to things like temperature. Higher temperatures causes gases to expand, which we'll talk about in other videos. Now, the stratosphere is important because the stratosphere is where the ozone layer is. Now, as you may have learned from reading your book, the ozone layer is a layer of gases in our atmosphere which protects us from UV light. It's a naturally occurring phenomenon. It's also important to realize that the ozone layer in the past has suffered damage from CFCs, particularly at the South Pole, but that damage has been gradually healing itself over time since the Montreal Protocols. Now above that is the mesosphere. And the mesosphere runs up to about 50 miles, stops at about 50 miles above the surface. Not a whole lot going in the mesosphere. The mesosphere is also meso in scientific language. In Greek, it is middle. So we often talk about things, use the word meso to mean middle. For example, the Mesozoic is the period of time in between the Paleozoic and the Cenozoic. So it's just this middle space before you get to the exciting thermosphere. And the thermosphere is the uppermost layer of the atmosphere. Now, technically, there is a layer above that called the exosphere, but it's so thin that it ceases to have any of the major features that we associate with our atmosphere. So usually, we would say that the end of the atmosphere ends at the thermosphere. And the thermosphere actually extends over 90 miles above the surface of the Earth. Now, with the thermosphere, one of its important features is that it is directly exposed to solar radiation. In other words, light from the sun. And that's going to become very important when we talk about its properties. So first, let's talk about pressure. Air pressure, we will indicate with this black marker here. Air pressure declines as we go up through the layers of the atmosphere. So starting at the troposphere, if this end over here is high, and this end over here is low, starts out very high, and as we go up, it might be easier for those who are accustomed to plotting this way, easier looking at it sideways. As we go higher in the atmosphere, pressure exponentially decreases. So why does pressure do that? Well, to understand why pressure does that, you have to understand what actually holds the atmosphere to the surface of the Earth. The atmosphere is actually held to the Earth by gravity. It's the force of gravity that holds the molecules in the air to the surface of the Earth. And those molecules have mass. And when mass is exposed to gravitational field, we call that weight. So in a very real sense, the air has weight to it. Now, it's higher pressure near the surface simply because there's more air on top of it that pushes down and squeezes the air molecules together, as opposed to higher up in the atmosphere, where there's not a lot of layers of air on top of it. You don't have a whole lot of air on. You don't have that wide swath of air, the other layers of the atmosphere on top of it, squeezing it down, and so it doesn't squeeze together as much. A good way to visualize this is a stack of sponges. So if you stacked sponges really high, the bottom sponge would be all squished together, and the top sponge would be all spread apart. That's a good way to visualize what the air molecules are doing. Now, when we talk about adiabatic changes much later, that idea of molecules being squished together or given plenty of space will be very important. Play a very important role in cloud formation and changes in temperature in the atmosphere and the troposphere. So now let's take a look at changes in temperature, and I'm going to indicate temperature with a blue marker. Temperature. Here's blue. Once again, we're not getting super specific. We're just going to go whether it's high or low. Actually, it's really hard to see that. So, red marker instead. That red marker. Red will indicate temperature. So, as we go up in the troposphere, what happens to the temperature? Remember, this end of the graph is high and this end of the graph is low. So, in the troposphere, it does kind of what most of us would expect it to do, which is the temperature decreases. But in the stratosphere, suddenly we have this huge change in temperature, and the temperature actually goes up like this. So we're just going to pause for a moment, and I'll put a little arrow here and say temperature increases. Now, why does it increase? The chemical reactions that are forming ozone and destroying the ozone actually, the destruction process absorbs UV light, but the creation process of ozone, the process of making ozone, actually releases heat. Now that might seem kind of strange, like how does a chemical reaction release heat? But we're familiar with that. For example, if you've ever used those little bags of hand warmers that you have to break apart, chemical reactions cause that to heat up. So in a very similar way, when ozone forms, it heats up. So there's basically that ozone layer is like a heat pack in the center of the stratosphere. Then in the mesosphere, we have the same process going on that we do down in the troposphere. As we go higher up, it gets cooler. This is once again from adiabatic cooling, which we'll talk about much more detail in another video. Now this topmost layer here in the thermosphere, Once again, we see it reversed. And we can say the temperature in the thermosphere increases. Now, why does the temperature in the thermosphere increase? There's no ozone, or very, very little ozone. There's not a particularly high concentration of ozone in the thermosphere. So why is the temperature increasing? And that goes back to that idea that it is directly exposed to solar radiation. It's the solar radiation on the thermosphere that's causing it to heat up. In exactly the same way that if you leave your car out in the sunshine on a bright, sunny summer day, the surface and interior of your car are going to be rather hot, but something underneath your car that's protected by its shadow is actually going to be cooler. So the thermosphere protects us from that solar radiation, and it's not just light from the sun, like regular visible light from the sun. It's also other forms of radiation, such as X-rays and gamma rays. When we get into the astronomy unit, we'll actually find out that the sun really isn't our friend and actually sends out a lot of things that are quite dangerous to life. So, I hope this helped clarify the different layers of the atmosphere. Please let me know through private message or the discussion boards if you would like further clarification.